Hello everyone and welcome to your Chem 113 review on molarity. My name is Jason and I work for the ASU Tutoring Centers. Well, we've been talking about solutions a lot lately. We talked about aqueous solutions, we talked about a little bit of electrochem, a little bit of acid-base chemistry. We were just sort of dipping our toes in the various areas there. Now we're going to talk about one of the most important parts of solutions, and that's molarity. What is this big M here? So that big M is 1 molar. So what a molar is, aside from a tooth in your mouth, 1 molar, it's 1 mole of solution, of solutes for every liter of solution. So think about it as sort of like a, just the amount of solute per solution. So if you have a high molarity, that means you have a lot of solute per solution. So you can almost think of it like, here's your beaker or whatever. So if you have high molarity, think about like all of the little particles you have, all of this little bit of solute you have a ton of it, just sort of hanging out inside of your solution. Not always visible, you know, depending on what your solute is. It can be kind of really fine, really small. Can't always see it. Whereas thinking about a low molarity, oops, I guess we're using this color, beaker. You have different colored beakers, you know. What that looks like is there's just less solute per liter. So see how dense this is and see how not all that dense that is? So essentially just, it's the concentration, you know, how much do you have per liter of solution? So we're going to use this definition to our advantage. We want to know how many grams of sodium sulfate are required to make 0.35 liters of 0.5 molar Na2SO4. So we start with 0.5 molar sodium sulfate. So 0.5 molar is 0.5 moles of sodium sulfate per 1 liter of solution. I'm not going to put sodium sulfate, it's 1 liter of solution. Okay? So we have, write the L a little better there. So 0.500 moles per 1 liter. How many liters do we have though? We have 0.35 liters. So if we write the 0.35 liters on top, we notice that the liters cancel out. So what we're left with now is just moles. So by multiplying molarity by liters, we're left with just moles. We have this many moles of sodium sulfate, but what it's asking for is grams. So we need to convert moles to grams using the molar mass of sodium sulfate, saving you some time. I just looked it up earlier. Of sodium sulfate, The moles cancel out, and then we just multiply everything across. Okay, so the 0.5 times the 0.35 times the 142.04. Taking care of our sig figs, we have 3 sig figs, and then 5 here. So our final answer will have 3 sig figs. It's 24.9 grams of sodium sulfate. Okay. So you just take the molarity, multiply by the number of liters, and that gives you moles. And then you can convert moles to grams using the molar mass. Okay. So we've been introduced now to one of the most important parts of solution chemistry is the molarity. And we will be using that a lot in the future. Wonderful. Well, thank you all very much. As I mentioned, I work for the ASU Tutoring Centers. If you want more information about the free tutoring services we offer on all 4 major ASU campuses and online, please check out tutoring.asu.edu/content/tutor-search. If you go here, you'll be able to find a tutor on your specific campus or online that will be able to help you with your specific course. Thank you again, and I hope you have a fantastic day.